We're mostly familiar with the basic operations of math. You have addition, you have multiplication, and you have exponentiation. This sequence is kind of interesting. Every operator in the sequence is the last one done a bunch of times over. 3 to the 4th power is 3 times itself 4 times. 3 times 4 is 3 added to itself 4 times. What if we want repeated exponentiation, though? What if we want 3 to the power of 3 4 times? Well, there's a way to do that. It's called tetration, and it's written like this. What this comes out to is 3 to the 3 to the 3 to the 3. A power tower of 3s, 4 terms tall. And it goes from top to bottom, so you get something that looks like this. So what is that number, really? Well, this first term is easy enough. 3 cubed is just 27. 3 to the 27 is a little harder. I have to use my calculator to figure out an answer, and it gives me about 7.6 trillion. That's already a pretty big number, and we're using it as our exponent, which means this number is going to be huge. But how huge exactly? I can't plug it into my calculator. I get an overflow error if I try. So we have to do something else. What happens when you multiply a number by 10? Well, you get an extra digit on that number, since you added a 0 on the end. A 2-digit number multiplied by 10 it becomes a 3-digit number. A 3-digit number becomes a 4-digit number, and so on. If you multiply a number by 9, usually the same thing happens. 9 is large enough that most numbers, when multiplied by 9, do get an extra digit. So if you multiply a bunch of 9s together, let's say n times, the number you get is going to be about n digits long. Well, that's what we're doing here, isn't it? 9 is just 3 squared. So this is equivalent to saying 9 times to the power of half of this number. So 3.8 trillion. Which means the number we get out of this is going to be about 3.8 trillion digits long. That's long enough that if you wrote it all out in a straight line with every digit being just 1 millimeter long, it would stretch all the way to the moon and back 5 times. That's what we got from a tiny tetration. We only did 3 teterated to the 4. Imagine if we had done to the 5th or the 6th. And we don't have to stop at tetrations. There are higher operations. If you want to repeat tetration, that's called pentation. Repeat that, it's called hexation. But given that we already have a number that's this large, I think we should probably stop now.